Hi, Yana. Sorry for taking so long to get back to you on those questions, but I thought it would be easier if I could make a video for you and have the screen showing while we're talking about the questions. Um, so the first question that you asked me was about the intersection of planes topic and how to prove whether planes are inconsistent or consistent. So I've got the lesson open here. And I'll just go through it with you and explain what they're trying to tell you in this lesson. And then alternatively, you could also search for this topic on something like Khan Academy or just, on Google and see if you can find another tutorial if this is not enough to explain it to you as well. So for three planes, for the system to be inconsistent, it means that it doesn't have a solution. So that means that there is no line of intersection between the three planes. That's what not having a solution would mean. So in the first case, one of the criteria for that to be true would be if two of the planes are parallel. So in this case, we have this plane parallel to this plane, so obviously they're never going to cross. And then the other plane can cross both of them wherever, but it doesn't matter because as long as those first two planes are parallel, they will never intersect. So you're never going to get a line of intersection for all three planes. In other words, a line that all three planes have in common. The second circumstance for where you would have an inconsistent solution is outlined in number 2, and that would be the case where you have all three planes being parallel to each other. So if that happens, then you would show that the direction vectors for all three planes are multiples of each other, which would mean that the planes are parallel and that they can't cross. I'm just going to move up to the next criteria here. So the next criteria that they outline, the third one, is that the planes intersect in pairs. So each plane intersects with one of the other planes, but there's no point where all three intersect at the same line. And so you can still find a point of intersection or line of intersection between two planes out of the three that you're given, but never for all three. And so they've outlined an example in each case here and shown you why these are inconsistent. So in each case, there's slightly different criteria, and you would just use the tests that you've learned, for instance, showing that the normal vectors or the direction vectors are multiples of each other and that type of thing to show that one of those three cases is true, and therefore your conclusion is that we have an inconsistent system of planes. So alternatively, we've got a consistent system outlined in the next part. So let me just go down to that. And so a system of three planes is consistent if it has one or more solutions. So here we are with number 1, with one example of how that can happen. The planes intersect in one line. So there's an infinite number of solutions because the equation of that line is your intersection, and so obviously every point on that line will be part of that intersection area. So they show an example here, and you can test that out to see what the line of intersection is. The second criteria is that the planes are coincident. And what that means is basically one plane is exactly the same as the other. One is lying right on top of the other. And so there's an infinite number of solutions because every single point on both of those planes intersects with the other plane because they really are the same plane. Both equations can be reduced to the same equation in that case, okay? Sorry, let's see what else they've got here for us. Okay, and a point of intersection being consistent. If the planes intersect in a point, there's only one solution. And so that would be similar to what they have shown in number 3 here. Number 3. And so they've given you an example of a system of 3 planes where there is only one point of intersection, and that also makes a consistent solution. So anytime that you get a consistent solution, it's going to result in a solution or solutions for the system of 3 planes. So I hope that that helps understand or explain that. Let me just check and see if there's anything more there that we need to talk about on this page. Otherwise, I'm going to make you another video. Yeah, I'll make you another video to answer your other questions that you sent me because I think they're from a different part of the lesson.